Hello everyone, this is my bidirectional converter. It converts the high voltage DC bus to 48 volts to charge batteries and vice versa, which means if the power in the HV bus is absent, the power will flow from batteries this low voltage to this high voltage to keep the inverter bus or the high voltage DC bus an uninterruptible power source. This is the microcontroller board. It contains a graphical LCD. It reads the voltage current of the input and output, and also decides what phase shift should be applied to the high voltage H bridge to obtain the required voltage. Currently I will test this by providing 300 volts from the mains after rectification, of course. The converter also contains this Wi-Fi small board to enable IoT or controlling the converter from any smart device like computer or phone across the internet or the local Wi-Fi. I also designed a simple application in C# that connects to the TCP server provided by the board and has a simple interface to control the board, like start command, stop command, and varying the phase shift to control the output voltage. Let's test the board by firstly we connect to the SSID of the board. It is ESP. It's already connected. Now we can use Telnet client or TCP client to test the output of the board. We can create a new connection and enter the IP address of the Wi-Fi of the microcontroller board. Connection refused. We must check Telnet, not SSH server. I didn't implement an SSH server. I implemented a simple TCP server. Now, these are the readings from the board, as you can see: current, voltage, phase shift, etc. Now, the TCP client program by C#, it reads these lines and translates it to a more convenient user interface. So let's start this project. It's already running. We can connect to the board first. See, connect first. It's connected. Now the phase shift is 170 degrees. The V out, V in, all zeros because we didn't apply power yet. We will plug this mains power supply. Now I didn't implement voltage input reading because it's non-isolated and dangerous, so I will read just the input current, output current, and output voltage. I use whole current sensor. These are isolated current sensors from LAM HISS 15S. For the input also I used two sensors. Now let's start the converter. Now the voltage raised to 45 volts. We can also control the output voltage by varying the phase shift. See the phase shift is the same, not here. We will change it to 150. We can also change it here from the board. See the same reading. The voltage also lower to 37 volts. We can set the phase shift to the maximum of 170. I think that's enough. 45 volts. Now let's load it, the converter, by this heater element. About 4 amperes. 4 amperes here too. The same reading is on the LCD board. We see the heater turn to red color. We'll stop the converter. As you can see, the board is completely controllable over Wi-Fi connection, and that's very cool, I think. This is my design. Bidirectional full bridge converter. The rating power is about 2 kilowatts. This is my DC source. It simply rectifies the mains voltage to a 300 volts, 320 volts approximately. The mains voltage is somehow low voltage. It's now about 255 volts DC. That's my board. This is the driver board that boosts the current capability of this driver board and supplied the signals, the PWM signals, to the converter by these transformer boards. These are isolated drivers for the IGBTs. These are 4 IGBTs. From the opposite side, these are the MOSFETs of the output stage. These are Amorphous Transformer. This is Amorphous Transformer of rating power about 2.5 kilowatts, about 22 turns in the primary and 5 plus 5 turns to the secondary.